chapter 17, flowing water, fluvial systems. Well, our last story was mountains falling apart, right? This one is about what happens next when broken stones begin their long journey to the sea, and, well, let's just see it all happen. Excuse me. Floodplains, places with very fertile soils usually because, well, every time it floods, usually there's a layer of soil that is laid down through time. Fertile Crescent being kind of one of the classic cases. While in this narrow arc of green stretching from the Nile to Mesopotamia, humankind first tamed grain, penned in animals, built cities. Here, but water was destiny, right? Too little, and the harvest failed. Too much, and the whole village could be washed away, right? From these rhythms came calendars and gods and mathematics, right? Tools that later civilizations used to, well, bargain with the floods. You know, the Nile River system, this is the delta of the Nile, right? You know, across the ages, humans have chosen to live beside rivers, not only because the soil is rich, the land is flat, water is close, but it's dangerous, right? The same rivers that feed the crops also rise without warning, reclaiming their plains, and civilization itself was born in these floodplains, Fertile Crescent. Well, from the rains in Uganda and the highlands of Ethiopia, the Nile gathers all this great soil, right, flowing northward. And remember, the Nile flows north. A lot of people, well, used to looking at the Mississippi, assume great rivers flow south. Flows north to the Mediterranean here. A delta is the main area where that, well, the good soils are spilling out to, and you could see the difference, right, in the landscape. Look at how much, well, more fruitful this landscape is here, right? You know, the water that's coming down the Nile, every drop carries the dust of mountains, ground fine by time, and lay it gently upon these fields. Civilization built its rhythm around the dependable breath, flood, reap, repeat. When I was in Egypt, a lot of tourists, utilizing that water and the water resources. Take a look at this map here. What is this? Well, this is where all of the water in the Nile comes from, right? Central Africa. We have Central Africa rains. Each rain brings nutrients from Central Africa, right? The rainforest, right? All of that organic material. You also see on here a whole bunch of dams. Well, you know, those dams create hydroelectric power. You could create storage for water, but also create a lot of political problems, right? Because if you're going to cut off a neighbor's water, Egypt of all these countries is kind of the wealthiest area and has the largest military. So if any of these other countries do something that Egypt doesn't like, it can have actual, well, repercussions. Luxor, Egypt. You know, this is papyrus growing here, which is, you know, the first paper was made out of that. And, you know, we don't really think about that too much. It's like, oh, that's right. They invented paper. An oasis. An oasis is a bit different because you have little dots of, well, water that is usually underground, but can have a little bit coming up. And then you could, you know, put wells around it. Again, Egypt, very dry place, right? That's part of the reason why so many of the ruins have been in good shape. Fruit cellar, and you can see how green that land is. That is closer to the Nile. When I went to Egypt, a lot of the canals are still in place. You know, much of the world had canals. They're still in place in Egypt because they're still a good way to convey water, even though that used to be a bunch of our transportation and how we cheaply sent things around. I'm going to show you the Aswan Dam. The Aswan Dam in Egypt. It's in the south of Egypt. So the Aswan Dam, so keep in mind when they decided to put this in, well, now it's a very dry area of the world, so this is a great reservoir, right? You put in a dam, and so you create a great big reservoir of water that you could use for all kinds of purposes, including irrigation. But half of this water is evaporated off, right? A big standing body of water in one of the driest regions in the world. And so although they have a lot of water that they are collecting because of new dam technology, well, they've sacrificed a lot of water because this is at the very beginning of the Nile in Egypt, so the whole rest of the length of Egypt. You also don't have your annual floods anymore, which is good because flooding can be chaotic, but also it means your topsoil, if your topsoil is lost, then it's just gone for good. But hydroelectric power, look in the map here. Do you see Egypt? This is a population map. You can see the majority of the population of Egypt are all along the Nile, right? Areas around it, the landscape is just kind of like very desolate. This is along the Nile, some areas that used to be farming, but there's been a bit of a soil loss, and so they've changed it to more grazing land. And as grazing land, it's not great, so you don't have like a lot of cattle. You have some. Nile quite wide, of course, number of areas. An example of how dry it is. These are bricks made out of mud, and they're thousand-year-old bricks made of mud, which is how a lot of bricks used to be made. But if there were bricks made out of mud in my home state, Minnesota, they would not last very long, right? A lot of the infrastructure in Egypt is put in place to convey water around. That's like why it exists. And the water is very highly treated. So if you go to Egypt, don't drink it out of the tap. It'll have a bit of a chlorine smell because it's very treated. And the water out of your tap is just for like cleaning things and whatnot, not really for drinking. Stream patterns. Let's see. I always prefer pictures and whatnot. Amazon basin. You could see a lot of stream patterns here, right? You see streams that are all emptying out into the Amazon. The Amazon itself, if memory serves, it doesn't have a single bridge across it, which is very unusual. But it's a wide river. It's like super wide, and so your bridge would just have to go on and on and on. Drainage basins, how are they defined? Well, a lot of different ways they're defined, right? And you also have sub-regional basins. And so basically, well, a river basin is any rain in that area all goes to that one river eventually, right? Eventually. And then you have sub-watersheds because that is areas that's smaller increments of smaller rivers and where those all empty off to. Drainage divides, right? If there's rain on the continent, where is it going? Continental divide along the Rockies, kind of an easy one to remember. Drainage systems, global drainage basins around the world. You can see why some of the largest rivers run through the center of a number of these. And if you look at South America, right, the Amazon one, huge. Dead Sea, although it's an inland sea, it's very salty because you have a lot of evaporation, right? Any place that has evaporation leaves behind salts. Just kind of a normal problem in such areas. Stream drainage patterns, as you can see, a wide variety, kind of depends on the landscape. Stream order, how does this work? Well, if you're trying to look at drainage and where everything is draining out to, this is definitely the pattern that you have. Anthropogenic intermittent streams. Of course, a lot of streams, well, Streams in nature are pretty flexible and move around, and that's not really how humans want them to be. So a lot of what we're doing affects where water goes and where we want streams to go. Erosion, similar to everything else. Remember that moving water is kinetic energy, right? So moving water will, the quicker it's moving, and usually it moves quicker the more downhill it is, the stronger it is. And so the more it will erode, right? And it erodes, and then it takes all that off to a delta, like at the end, right? Urbanization, of course, our urban landscapes that we're building all over, the water runs off of them, right? And so, if we're putting in a new development, a lot of developers are just trying to figure out where's that water going to go that used to go into the soil, right? The natural process is water goes into soil, and then it's kind of slowly absorbed, and then it slowly moves down towards streams and rivers. But as humans have just put in more and more stuff, that water runs off. This is actually a picture from Florida. And a lot of their planning has to do with where's this water going to go, so it's not flooding out the very buildings that we're making, right? Parking lots, that's not an area that's absorbing water. Urbanization and stream effects, when we are having floods and stuff, you probably will notice it on the news. Increasingly, these are like in downtowns, because that is kind of where the most urbanization is, right? Although suburbs are kind of catching up. You don't need to know the math of streams. I always prefer images. This is the kind of thing that was in the previous image. If you've ever been driving around and you've seen these kind of out somewhere seemingly randomly, it's not random. These are to try to look at, how much water there is, how much rain there's been, trying to collect data so that people can predict flooding. It's still very difficult to predict this flooding just because, there's always new developments and things going in, right? In a nutshell, you have a big rain, and then a standard amount of time later, you can have a flood, right? And usually you could predict when it's going to reach its height, but not always. Especially since, it gets harder and harder to do the analysis with the more development that goes in. But also on top of that, our technology will hopefully move forward and allow us to figure this out more. Rounded rocks, right? This is why if you've ever, going down a river, it's like, the rocks are nice and round. It's like, that's the water, right? Water doing its work. You could also usually tell just by looking at a river how much kind of stuff it has in it. Some abrasion potholes. In a nutshell, smaller particles tend to go further and be higher up in water. But if you've ever been tubing down a river and you put your hand down and it's a rocky part, you may even feel these rocks moving. The rocks themselves also, even pretty big ones, slowly moving downriver. Now you can see this stream here, right, has a lot in it, right? That's literally how you can tell how much material is in. You could just look at it, right? Streams that tend to be slower, that stuff settles down. If a stream is quicker, or depending on where a stream comes from. If it comes from an area that there's mountains and so there's a larger angle, it will be wearing away more material. Stream grading and gradient, that's just how steep it is, right? And so like I said, the steeper, the more of that kinetic energy is in that body of water. This image here where it shows the mouth at base level, that's also where deltas form, right? And you can see why a delta would kind of like spread out in the way we've seen them. It's because all that material keeps on being laid down. And a lot of the material goes out in the ocean, and sometimes that's good for local ecosystems, sometimes that's bad. Example of like the steepest angle would be, obviously a waterfall, right? When it's going straight down. Some people, in video clips, you'll see diving in these areas. Be careful if you do that, because very often you could have worn away material and it could be a lot less deep than you would think. So make sure you know where you're jumping before you jump in. Valleys, how are these carved out by a stream for ages and ages, right? Stronger the angle of the V shape, the more stuff falls into it, but the river carries that away. Right? And it depends on the underlying rock, right? You have a mixture of hard and soft rock here, right? And so they degrade at different rates, right? Vertical joints very often leave very great landscapes to go hiking in and whatnot. Stream rejuvenation, well, not done by humans, I guess I wouldn't say. But streams, well, again, humans want these to be in steady, reliable patterns, right? Because we were building cities around them. Naturally, that's not really how they are, right? You get some uplift here, and this gets the stream moving quicker and kind of changes up the dynamic, right? The exact same place, the stream can be completely different depending on different time frames, and this can happen quickly. Sometimes, especially meandering. A meandering stream, you don't even necessarily have to have the land changing shape. But the stream itself, as it eats away, this is an example where it's like basically through rock, right? So that's much more steady. But when you have meandering streams through all kinds of landscapes. Oops. Oh, sorry, my clicker is not working. Stream capture, like I said, streams go all over, and humans can do this as well, and but it can also be a natural process of streams moving around. It's natural for streams to move around all the time, and us not wanting that to happen and kind of freezing physical geographic processes in place can have negative repercussions sometimes. Stream sorting, stream settlement, well, in a nutshell, as the stream brings stuff and it lays it down, and it could be in different layers, kind of depending on the time frame of that stream and what is being dissolved in that stream. If a mountain gets dissolved away and then you have sand or something else underneath it, then that's a thing that will come. But also, well, as things go in streams, like we saw in the other image, heavier things go to the bottom, lighter things go to the top. And so depending on how fast that water is moving, sometimes you can get these things mixed, but sometimes they get very stratified layers. Or I would also say different parts of a stream can be going at different speeds, and so that means the stuff that it will lay down could be different sizes, right? Kind of depending. A slow-moving stream tends to not be able to carry much in it. Hydraulic mining, you'd be shocked to see how much water is used. I would say we hear about water use in news stories about AI a lot, but they don't really go into too much detail about how much is used for industry, how much is used for agriculture, which is a ton more. And water at high pressure can of course cut through rock. High enough pressure can cut through anything. And so this has been used for mining. But when it is used for mining, of course, everything washes out to somewhere. And sometimes you're washing out lots of chemicals, kind of depending on what the mining facility is. Now, this is an example of braided streams. This is water that's going very slow, right? But what happens is it leaves debris and it cuts itself off, and then it braids, because when it cuts itself off, the water has to keep flowing, and it will just braid a different area, You could do like a lot of whitewater rafting in areas like this. I did that in Alaska and landscape that was very similar. Because, well, there, similar to here, it was great glacial melt, right? The glacier melting, that water isn't coming down fast, right? It's melting glacier. It's a slow trickle. Another example. And these patterns are just constantly changing, Alluvial fan, again, that's just debris. Rivers themselves and the process of them changing their own shape, well, you can even go down to like the Mississippi. And if you look at it, you could see one side is having more erosion than the other side. And what we usually do is we put in concrete and all kinds of stuff because we don't want these to change where they are, right? Because most of these rivers run through great big cities. Oxbow Lake, we have a number of those in Minnesota because, well, we have lots of bodies of water. But what happens is you could have a meander that just cuts itself off, that jumps, the meander neck there. This is what these look like in the landscape a bit. Again, this is the process, right? You could have an original river that went like this, and then through time, as it erodes one side and it deposits on the other side, right? Because you have the water is moving more quickly. The more it meanders, the quicker the water is moving on that side that it's taking away from, and then it's depositing on the other, and eventually, like this is the natural process for streams. But we don't really want them to look like that. There's a Yazoo stream. That is a stream that runs next to a major river but doesn't actually ever connect to it. There is a Yazoo stream with the Mississippi, and I believe it's just called Yazoo. I think but that's the term for the type of stream as well. So that wasn't very inventive as far as their naming of lakes. Again, on the landscape, what's that going to look like? Right, some more examples. Base level, right? This is where everything is kind of going to, usually. A delta, which I showed you pictures of earlier. I didn't show you a Mississippi delta, right? Where's all the stuff in the Mississippi River washing out to? It's washing out to this delta. Delta shapes really depends on how fast that water is going, right? If it's kind of coming out slowly, it could have this kind of thicker shape. If it's coming out pretty rapidly and there's a lot of it, it kind of like shoots that material out further, so it's a bit more sprawling. Like I said, human effects to all these areas. We are changing the earth in all kinds of ways. I don't know if people ever went to New Orleans, but it's a bit weird because you can kind of be in a part of the city and you could look out at the ocean and you could see that you're lower than the ocean is, right? And it's like, well, yeah, it's because it's sinking through time, and you could put up a lot of barriers and whatnot. But if a big storm comes through, like Hurricane Katrina came through, if your land is below sea level, if a hurricane with a storm surge comes through, it's going to do a lot of damage. Stream flooding, like I said, flooding is becoming more and more of a problem, mostly because of human landscapes. South Asia. Now, the monsoon in South Asia, this is an annual thing, right? Places that have monsoon climates can have a very wet season with lots of flooding that everyone knows kind of happens, right? That's just an expected part of life. Just like in Minnesota, we know we're got to deal with snow some percentage of our life, right? You can see here, well, you have these warm and moist weather patterns coming from the ocean, and they go up and they hit that mountain and they rain, right? And so you get a huge amount of rain, but it's seasonal. The same place in the dry season, when the winds have gone the opposite direction, you could have no rain for half a year. But places like India, Bangladesh, they get enough rain that they have enough in their groundwater to get them through those times. But on the ground, like, your weather's very different. This is a bit when I was in India. A lot of deforestation, especially during the colonial era. You could, when you get deforestation, these are basically signs saying don't cut down these trees that are protected. The original tree huggers were from India. Tree huggers, that term came from, well, you would have farmers who you would have people come in and chop the trees that were around their farm, and then when the monsoon rains would come, it would wash it all away. And so farmers, when people come to chop the trees, would literally wrap their bodies around the trees because there was nothing else they could do, and that didn't always stop the axe. And so, what do you have in a landscape after your entire topsoil is washed away? Something like this, right? Now, these areas are protected now, and you can see that there were a few trees that were able to kind of survive after the soil was lost. You can usually tell how much topsoil loss there's been by those roots and how exposed they are. But like I said, these are in protected areas. These are actually behind a big fence. And I'm surprised the trees are able to still survive. I guess they have pretty deep roots. But that's the other thing, too, is you cut down the trees. The roots aren't holding the landscape together. The next big rain, it all gets washed off. And this is the Ganges, which is one of the main rivers discussed in this chapter. And I know you see that swastika on the side. It's not that there are Nazis in India. Hitler stole that sign from India, which had used that symbol for thousands of years, and just the Nazis just took it. So don't get confused about that. This is the dry season, and this is also the river at its lowest point. But the Ganges River is considered a sacred river, right? You've probably seen people bathing, doing ceremonial bathing. This is the dry season, so the water's at a low point, so you could see old temples kind of half submerged. One of the ironies, you can see that there's like a lot of garbage here. Spiritually and among the religion, this is considered a purifying waters, but similar to rivers all over the world, it's very polluted. There's industry doing all kinds of toxic chemicals and stuff. So, me as a foreigner, I would consider this not clean, but religiously, it's considered clean and a purifying thing. And so people have pilgrimages here to do the bathing, set up little tents and whatnot if they go on a pilgrimage. Like I said, it's very polluted, but culturally considered pure. Flood management structures, again, humans don't want all this moving around to the bodies of water. We want them to stay in place, right? You just saw the Ganges with all kinds of infrastructure all over it, right, to keep it in place. Dam pros and cons. Well, it's a source of power that doesn't emit carbon, but it really messes up ecosystems, right? Because if you dam up a stream, you're not really going to have fish or other creatures kind of migrating through. Much of the world is kind of in a stage of building lots of dams, similar to we were many years ago. Because it is a source of power, and also you make a reservoir, right, where you have all this water stored up for whatever you need it for. But there are places where dams are underused, and maybe it's to an advantage to reconnect these ecosystems. It kind of depends. And that's it.